This section is all about the difference quotient. And the difference quotient is used in calculus to calculate what is called a derivative. And so our focus is on the algebra. Right? I've said before in calculus, before you can do any calculus, you got to do a whole bunch of algebra. Okay? So Lily, can you keep your mask pulled up, please? Okay? College policy. Okay? So before you can do any in calculus, before you can do any calculus, you got to do a whole bunch of algebra. Okay? And so the difference quotient is used in calculating what's called a derivative in calculus. So we're going to be focusing on the algebra of the difference quotient. Okay? And so this guy right down here is C, f of x plus h minus f of x over h is called the difference quotient. Okay? So in example 1, we're given f of x is equal to 4x squared minus 2x plus 9. So in step 1, or part A, we have to calculate f of x plus h. So how do we evaluate f of x plus h? You just put x plus h in for x on the right-hand side of f of x, right? And so we have 4 times x plus h squared minus 2 times x plus h plus 9. Now there's not a lot of space, so I'm going to go straight across like I did in my notes. Okay? So now we got to expand this, right? So we got to expand x plus h squared. We got to FOIL it. Remember, okay, x plus h squared is just x plus h times x plus h, right? And so when you FOIL that, you get x squared plus 2hx plus h squared and then you got to distribute the minus 2 inside the parentheses. We have minus 2x minus 2h. Then lastly we have the plus 9. And now, lastly, we got to distribute the 4 inside the parentheses here. We have 4x squared plus 8hx plus 4h squared minus 2x minus 2h plus 9. Okay. And there are no like terms in that expression. So that's what f of x plus h is equal to. Okay? So now in B, we got to evaluate f of x plus h minus f of x. So f of x plus h is all this in the rectangle. 4x squared plus 8hx plus 4h squared minus 2x minus 2h plus 9 minus now f of x. And since f of x has more than one term in it, put it in parentheses or you won't distribute the minus sign correctly. We have 4x squared minus 2x plus 9. Okay. Now when we distribute the minus sign, we're going to have 4x squared plus 8hx plus 4h squared minus 2x minus 2h plus 9. And now we distribute the minus sign. And so we distribute the minus sign, inside parentheses, we have minus 4x squared plus 2x minus 9. Now, this quadratic function is actually a polynomial, right, of degree 2. So whenever your function is a polynomial, when you do f of x plus h minus f of x, all these terms in the polynomial will cancel. Okay? So you notice we got 4x squared minus 4x squared. We have minus 2x plus 2x. We have 9 minus 9. And so we are left with 8hx plus 4h squared minus 2h. So that's the numerator of the difference quotient. Okay? Any questions on that thus far? All right, so in C, we now got to calculate. We're going to take f of x plus h minus f of x and divide it by h. Okay? So we got to take this and divide it by h. So when we do that, we have 8hx plus 4h squared minus 2h divided by h, right? So I'm just dividing the left-hand side and the right-hand side by h. Well, you know that division does not undo addition and subtraction. So each of these terms in the numerator have to be divided by h. So we have 8hx divided by h plus 4h squared divided by h minus 2h divided by h. Okay. Well, the h's cancel here, and we're left with 8x. Using the rules of exponents, h squared divided by h is just h. So the second term simplifies to 4h. And then the last term, the h's cancel, and we're left with minus 2. So the difference quotient for this problem, f of x plus h minus f of x over h, is equal to 8x plus 4h minus 2. Now we can do the calculus. Okay? Are you with me? So this is a perfect example that before you can do any calculus, you got to do a whole bunch of algebra. That's not unusual. All right. Any questions? All right, so let's look at example 2. F of x is equal to the square root of x plus 1 minus 3. So in A, we gotta find f of x plus h. So we replace x on the right hand side of this f of x with x plus h. And when we do that, we have the square root of x plus h plus 1. Then minus is 3. In B, we gotta find f of x plus h minus f of x. Well, f of x plus h is the square root of x plus h plus 1 minus 3. And then we gotta subtract f of x. Well, f of x has more than 2 terms, so be sure to put f of x in parentheses. It's minus square root of x plus 1 minus 3. And now you got to distribute the minus sign inside the parentheses. And we have square root of x plus h plus 1 minus 3 minus the square root of x plus 1 plus 3. And now you can see minus 3 plus 3 equals 0, cancels. And we are left with the square root of x plus h plus 1 minus the square root of x plus 1. So that's what f of x plus h minus f of x looks like. Okay. And now we got to divide by h. To get the difference quotient for this problem. So I divide both sides by h. I have in the numerator square root of x plus h plus 1 minus the square root of x plus 1 divided by h. And I didn't go beyond that. Okay? Any questions on that, ladies and gentlemen? Okay? So flip over your page to example 3. In example 3, f of x, right, is a quadratic function again. 7x minus 3x squared minus 4, right? That's a quadratic function or a polynomial of degree 2. So first step, evaluate f of x plus h. So we replace x on the right hand side of f of x with x plus h. So 7 times x plus h minus 3 times x plus h squared minus 4. So you got to distribute the 7 inside the parentheses here. So we have 7x plus 7h. And then we gotta expand x plus h squared. We did that in the first example. That's x squared plus 2hx plus h squared. And then we have the minus 4. Well, you gotta distribute the minus 3 inside the parentheses here. And we have 7x plus 7h minus 3x squared minus 6hx minus 3h squared minus 4. And there are no like terms. Okay? So, next step, evaluate f of x plus h minus f of x. So we have 7x plus 7h minus 3x squared minus 6hx minus 3h squared minus 4 minus f of x in parentheses because it has more than one term. 7x minus 3x squared minus 4. So now we got to distribute the minus sign inside the parentheses. We have 7x plus 7h minus 3x squared minus 6hx minus 3h squared minus 4. Then we distribute the minus sign. We have minus 7x plus 3x squared plus 4. And again, because this is a polynomial, all the terms involving f of x should cancel. So we have 7x minus 7x, we have minus 3x squared plus 3x squared, we have minus 4 plus 4. Right? So all that cancels, and we're left with 7h minus 6hx minus 3h squared. Now only one thing left to do. Divide by h, right? So we have f of x plus h minus f of x. Right? We're going to divide the left side and the right side by h. And when we divide the right-hand side by h, division does not undo subtraction. We have to divide each of those terms by h, right? So we have 7h divided by h minus 6hx divided by h minus 3h squared divided by h. Which is equal to the first term, the h's cancel. We're left with 7. And the second term, the h's cancel. Right? These h's cancel. These h's cancel. And we're left with minus 6x in the second term. And then in the third term, h squared divided by h is just h. And we're left with minus 3h. So that's what the difference quotient is equal to for this example. 7 minus 6x minus 3h. Okay. Any questions on that? Okay. On example 4, f of x, this is going to be a little more complicated. F of x is equal to 2 over 4x plus 1. So f of x plus h is equal to 2 over 4 times x plus h plus 1. And when you distribute the 4 inside the parentheses, you have 2 over 4x plus 4h plus 1. Now we got to do f of x plus h minus f of x. Well, f of x plus h is equal to 2 over 4x plus 4h plus 1. And then we got to subtract f of x, which is 2 over 4x plus 1. Okay. So here's where it gets a little challenging. We're taking the difference of two fractions, and we take the difference of two fractions, you need a common denominator. So the common denominator is 4x plus 4h plus 1 times 4x plus 1, right? So we got to multiply top and bottom of this fraction by 4x plus 1, and top and bottom of this fraction by 4x plus 4h plus 1. Okay. So I'm going to do two steps at once. Right? We'll multiply top and bottom of each of these with the common denominator, and then I'm going to combine the numerators. Okay? So this first fraction, multiply top and bottom by 4x plus 1. And then we subtract, and we multiply top and bottom of the second fraction by 4x plus 4h plus 1. So we have minus 2 times 4x plus 4h plus 1. Okay? So I did two steps at once. Multiply top and bottom of this fraction by 4x plus 1. Multiply top and bottom of this fraction by 4x plus 4h plus 1. And then I combine the numerators. Okay? All right. So now we got to distribute the 2 inside parentheses here and minus 2 inside parentheses here. So when we do that, when we multiply, distribute 2 inside parentheses here, we have 8x plus 2. And then when we distribute the minus 2 inside parentheses here, we have minus 8x minus 8h minus 2 all over the common denominator. Four x plus 4h plus 1 times 4x plus 1. Okay. Well, in the numerator, there are terms that cancel, right? We got 8x minus 8x, we got 2 minus 2, and we're just left with minus 8h in the numerator. And minus 8h in the numerator over the common denominator 4x plus 4h plus 1 times 4x plus 1. Okay? So that's what 4x plus h minus 4x is equal to. Okay? Now we got to divide by h to get the difference quotient. So we have f of x plus h minus f of x over h on the left. And now we got to divide this quotient, this fraction, by h. So we have minus 8h over the common denominator 4x plus 4h plus 1 times 4x plus 1. Right? So we got that quotient over there divided by h. Remember, this is the main fraction bar. Fraction bars are like division symbols. So we have this fraction divided by h. And when you're doing division with fractions, you keep the first fraction or number, change division to multiplication, flip the second number. So the first number is minus, right, is this numerator, minus 8h over 4x plus 4h plus 1 times 4x plus 1. And then we change division to multiplication. And then we flip the bottom number. So h is the same as h over 1. So when you flip h over 1, you get 1 over h. So this is equal to 1 over h. Keep the fraction on top, switch division to multiplication, flip the denominator. So h becomes 1 over h. Well, you can see when we multiply, these h's cancel. And then when you multiply straight across, you end up with minus 8. Right, minus 8 times 1 is just minus 8 over the common denominator. 4x plus 4h plus 1 times 4x plus 1. And after a whole bunch of algebra, we finally find the difference quotient. Okay. And now we can do some calculus. Any questions on that? Nada? Okay. All right, so flip over to page 3. Now, what I suggest you do is the back page, page 4, is blank. So I suggest that you scratch out this problem B and do it on page 4, the back page. I couldn't get all my work in this little space up here, right? I had to use the whole page. Okay. All right. So before we do that, bottom page 2 defines what the derivative is. Okay. Now we did limits for exam 1. Remember when we did limits? As x approaches some number for some function, okay? Well, the derivative of the function f at x is denoted with this notation, f prime of, that's f prime of x. And f prime of x is equal to limit as h goes to 0, not x, as h goes to 0 of the difference quotient. Okay. So let's find the derivative for f of x equals square root of 2x minus 5. So f of x is equal to the square root of 2x minus 5. Okay. So we got to find the difference quotient first. So we got to find f of x plus h minus f of x divided by h. Okay. Well, f of x plus h, I just put x plus h in for x on the right hand side, right? And so I have the square root of 2 times x plus h minus 5. And then we subtract f of x, which is square root of 2x minus 5, divided by h. Okay? And now when I distribute the 2 inside the parentheses here, right, under the square root, I have 2x plus 2h minus 5 under the square root, and then we're subtracting square root 2x minus 5. And all that's over h. Okay. Well, let's do an aside at the top of the page. Okay. Above where it says compute the derivative. The derivative f prime of x is equal to the limit as h goes to 0 of the difference quotient. F of x plus h minus f of x over h. So when we replace the difference quotient with this right here, we have the limit as h goes to 0 of 2x plus 2h minus 5 minus the square root of 2x minus 5 all over h. Well, you know the first step is direct substitution, right? So if I put 0 in for h here, I have 2 times 0, which is 0, and I'm left with the square root of 2x minus 5. So we have the square root of 2x minus 5 minus the square root of 2x minus 5. Anything minus itself is 0. And when I put 0 in for h down here, I have 0. So I have 0 over 0 form. And from chapter 1, what we know is that if you have, when you do the direct substitution, if you get 0 divided by 0, 0 divided by 0 is undefined, but the limit may still exist. You had that on exam 1, where I gave you a function where then the limit, it was 0 over 0 form, but the limit still existed. So we got some work to do over here. What we're going to do is rationalize the numerator. And to rationalize the numerator, we gotta multiply top and bottom by the conjugate of the numerator. So the conjugate is a reminder. Of A minus B. Is what? Do you remember? Say what? You remember how to find the conjugate? Huh? It's A plus B. You just change minus to plus. So what we're going to do is multiply top and bottom by this square root plus this square root. And what we're doing, we're going to rationalize the numerator. Okay? You may forget, I mean, we cover a lot of math in one semester, but we talked about this in chapter 1. Okay? Rationalize the numerator and rationalize the denominator. Okay? And to do that, we got to use the conjugate. Okay? But we're going to stop right here because I don't want to try to blow through these problems in 3 minutes. Okay? And we will pick it up right here on Wednesday. So this homework will be due Thursday. Okay, but you still got one due tonight. Okay, before that.